Perfect. So, welcome everybody. Today's class is going to be a continuation of yesterday's class, which was totally related to how we can construct a virtual environment using the canvas. Yesterday I was talking a lot about how to use the canvas to draw things, but I want to just go a little bit beyond and start exploring what you can do if you just make the drawing a little bit more intelligent. So you put everything on the right place. So for that purpose, I'm going to continue with the slides. So 1 second, let me search for the slides. So yeah, here, yes. Okay, so currently what I have in the code, I have this code here, and this is just the code I had yesterday, but I cleaned it up a little bit to be a little bit more, well, all in a single place. I put all the global variables on top. So more or less exactly what we had yesterday, okay? And if we execute this, you can expect to see a canvas, which is, I don't have set up the size, you will see why. And I'm just rendering a rectangle here, okay? And just to be sure that everything works well, instead of rendering the rectangle in position 1010, I'm going to just use the mouse position. Oops. 0 and 1. So now if I reload this, you can see that the mouse, the square is being rendered on the position of the mouse. So good, means that we are doing, well, at least we are getting the input right. Okay, so can we transform this in something that makes more sense? That's what we're going to do today. So in this presentation, sorry, it says, okay, slideshow, yep. Okay, well, besides all the things that we talked the other day about how to read the mouse and everything, I added also the code to read the keyboard. You can see here to read the keyboard is super straightforward. Only thing I'm doing is just I create an object, call it keys. It's a dictionary where I'm going to store everything about the keys. And then I'm going to, when the user, I capture the key down and key up, but I capture it for the whole body, not just one element, because I want any key that's present on the keyboard, I want to capture it. And if the key is a key, it's a key down, I call the function key down, which what it does, it just stores in this object here if the key was pressed, and when it's released, it stores that the key was released, so true or false. That means in any moment, if I go to this object, I can see which keys are pressed and which keys are not pressed, okay? And well, it's kind of simple on the mouse. I didn't explain the other day, but I also capturing the mouse events on the whole body, and I'm calling this function, and in this function I'm transforming the coordinate of the mouse that comes from the event. These ones over here. These ones, the problem is that they come based on the coordinate system of the whole website, but I usually want the coordinates on the canvas space. That means on the 0, 0 has to be on the corner of the canvas, not the corner of the website. So what I do is I compute the position of the canvas on the screen, and I subtract the position. So I have now in mouse position, when the mouse moves, I always have the latest position. I also get the buttons. This gives you the state of the buttons, which buttons are pressed. So with these two informations, I have enough to read the mouse and do whatever I want to. Okay, so as I said, we have the very basic things for drawing. Okay, so today, instead of having a regular website where we put the canvas somewhere like in some divs and so, I'm going to go with a full-size canvas. And the idea is that sometimes when you make an application, you want to render something that it takes the whole screen. So for that purpose, what I'm going to do is first on my code, my style, I remove all the margins and all the paddings, everything, to be sure there's nothing in the middle. And in my HTML, I only have the canvas. I don't have a divs or anything else. We can have divs. We will see that later. But for now, I only have the canvas. Okay. So what I'm going to do now is I'm going to try to be sure that this canvas goes from one point of my screen to the other point of my screen. How can you do that? I'm going to resize the canvas, but I'm going to resize the canvas based on the size of the parent. This function here, well, I go to the canvas, I get the parent node, and in this case it's going to be the body, and when I have the body, I'm going to, sorry, the main container, I'm going to get the size of this container, and I'm going to get the width and the height, and I'm going to assign it to the canvas width and height, okay? And also I'm going to add something on the style I didn't do, which I forgot, which is that if there is any overflow, I want it to be hidden. I don't want to have scroll bars, okay? So just by doing this, if I go now to, I'm going to copy the code I was showing you, this code over here. Okay, and I'm going to put this code on my code.js here at the very beginning when we start rendering. I will even do it before I get the context because I don't need the context. So now every time I draw a frame, the first thing I do is be sure that the size of my canvas is the size of the whole screen, okay? And if I do that, and I go back to the website and I reload, you will see that now the canvas goes from one side to the other side, okay? It has exactly the same size as the screen. There's this white line because I have put a border. I'm going to remove the border from the style because now it doesn't make any sense, okay? And that's it. We have what is called a full screen image. The nice thing is if I, in any moment I want to go full screen, real full screen, I'm going to press F11 to go full screen. So it still is going to adapt to the whole size of the screen. And I have as many pixels as my screen has pixels. So that's a very nice full screen application that I can use for whatever I want to, okay? Somebody could say, yes, but I want to have divs. This way I don't have divs. Well, you can always have divs if you want to, because you can overlap divs on top of this canvas. You can have like a panel here floating if you want to, or like semi-transparent, something like that, if you want it. If you don't want to have it like this, it's okay. You can put this canvas inside another container, like a div, and assign the size of the div, and this canvas will adapt to that div. Okay, so I mean, you always have options if you want to adapt the size of this canvas however you want to. But what is important that you realize, and this is something that some of you may make a mistake, some of you, instead of doing this I have done now, I'm going to comment this line so to show you a common error. Okay, so now the canvas is going to be not full screen. Now you can see that it's not full screen only until here. Some of you may be tempted to say, oh, but that's way easier, Javi. You don't have to do that. You say that the width is 100% and the height is 100%. That way the canvas will measure the whole size of the container. In this case, it's the body. But if you do that, you will see this. Okay, weird thing that the mouse doesn't is in the right position. And also, if you pay attention, you will see that the square looks more blurry. And the reason why it's blurry is because we still have the same canvas as we have before. It's just that it's being stretched. So we have the same amount of pixels as we have before we did the width and the height, but the problem is that those pixels are being stretched from side to side. So the canvas, we can say, is something like this size of the canvas, and what is doing the CSS is stretching these pixels to look the whole screen, which is going to deform depending on the size of the canvas, and it's also going to make more blurry because there's less pixels for the whole screen, stuff like that. So always, when you work with canvas, never do resize by CSS. You have to do the resize manually from code, because you want to tell the code, and that's the important thing, you want to tell the code that this canvas has as many pixels, okay? And this is not modifying the canvas itself, it's not modifying the way we display the canvas. But when you change the code here, you're telling the JavaScript and the canvas, hey, this canvas has to have as many pixels as this says, okay? Cool, I hope this was clear. So now we go back here, 1 second. Okay, so now we have our canvas, and we can draw whatever we want. Cool. More things. What we want to draw? That should be the first question. Let's go to the next slide. I don't know the order of the slides, so we will see. Detecting mouse over. Okay. Well, first I want to talk more about, well, I'm going to stop here and I'm going to talk more about what we want to draw. Okay, for today I want to draw something that looks more like a chat, like a real chat with characters that walk around, something similar to Havo or other chats where you have an embodiment. Embodiment is a topic that we will discuss next week probably, and the importance that your representation on the chat has some kind of character, because that makes you feel more attached to the personality of the character, and also that helps people to empathize with you. So for that we need to have a person on the screen. Okay, so I'm going to jump the slides in different order now because I want to start talking about what we're going to render. So before I do that, I want to show you how you can clean up the code, because if I start doing it wrong, it's going to end up being a horrible code. So as you see, this code that we have now, it has a lot of code that we are not going to modify I mean, I'm not going to modify the way we compute the upset time. I'm not going to modify the way we have this manager for pictures, or I'm not going to modify the way we read the mouse or we read the keyboard, okay? So this is more like a low-level layer that we're using mostly to start up our application and get all the events that we need. But the truth is, it would be nice that our application is not here, because if it's here, it's going to be ugly. So I have created this my app, which is much more beautiful, and I'm going to put here some events, like for instance, maybe an init function could be nice. Also, obviously, we are going to have a draw function, and the draw function will receive the canvas and the context already, so I don't have to get it here. And also, I'm going to have an update function. Is going to receive the delta time, okay? So as you can see, this is more clean to work because everything I have here is the things I need to modify. All the other things I was showing you before, I don't need them. So because I have everything in the structure here, it doesn't take much time to go to my code and try to redirect all the actions I'm doing here to the other file. So first of all, I'm going to first call here my init, okay? Because I want to init this application once. So I'm going to put it here. And the next thing I'm going to say, okay, the draw. I have here the function draw. When do we call the function draw? From our draw here. Cool. Then I'm going to just remove here this code. Maybe I can put it already here. Okay. And I'm going to go here and say, so once I have the context and the canvas, I'm going to go to my app. Oops. I'm going to go draw, and I'm going to pass the canvas and context. The canvas, I don't need to pass it because it's a global variable, and because it's global here, it's also global here. But still, it looks more clean to do it this way. In case I have, imagine I have several canvas. This is something that maybe can happen. Okay, so yeah, cool. And the update the same. I'm not going to modify the update here. Well, yeah, I can do this here. I was going to modify it directly on the loop. So when I call update, here I can call my app update. But I'm going to leave it here in case I want to reuse this code in the future. Cool. And finally, when you touch the mouse, maybe I want to send an event. My app on mouse, I'm going to send an event here. And I'm going to remove this because, well, maybe I don't need it now, but I may need it in the future. So on mouse, in case I want to capture some event. Okay, I'm going to leave it here. I'm not going to use it now, I think. I don't have any use case for that. But at least I have the code much more clear, okay? So you see, way simpler file, and I will never go back to this file. I don't care about this file. If I want to add something else, maybe I can go here, see, on key, events. So if I want to control when the user press a key, maybe also useful to put it here on key. Okay, and that's it. And if I reload now the application and everything is right, what I should be seeing is exactly the same. As you can see, it's exactly the same, but it's way more clean code. And this is something I've been always explaining to you, and it's important that you get used to this. Like, you make your life easier. You don't have to wait other people to tell you how you have to code your application. Just make it in a way that looks clean and simple. So now I have an application, but the next question is what's my goal to draw? We're going to go with drawing maybe a room. I want to check if I have 1 second. If I have here from the slides. One second, I'm searching for something on the slides. Yeah. So this is what I want to achieve on today's class. So let's make this slide. This is very, very simple. It's not so many slides. Well, it's kind of a lot of slides. I want to go with something simpler. Anyway, I want to talk about virtual spaces, okay? And the kind of virtual spaces that we want to create today is one with the canvas. But let's talk about the idea of how the internet has evolved. And I will go back to these slides next week. But for now, just think about the idea that we started using in the 90s the internet just to search for information. Then in the 2000s, we used the internet to communicate with people. And in 2010, we started using the internet more to interact with the information and to share information with other people using the social networks, okay? And so now it's like we expect that now the thing should be more focused on users interacting with users directly, not through a more like a information. And in that sense, it makes sense to work on a virtual space. And I was always asking the people if you know which, or you can guess which, when it was released the first virtual space online commercially that you could use. If you know which one it was, or you can guess which year it was the first time that there was a virtual space where you can connect online and start moving around with your character and talk with other people. Anybody wants to try to throw a guess of the year, or at least the decade where this was first introduced? Because usually when we think about virtual spaces, we always think about well, more modern things like 3D things and things. But okay, nobody's typing on the chat. 2008. Ooh, no, that's too way sooner. Was 2005? Nope, way sooner, way sooner than 98. I'm going to give you, it was on the 80s, on 87. On 87, for the Commodore 64, it was an 8 bits computer. There was Habitat, which is a game where you can connect with your modem and you can walk around and talk with other people. And it's super nice. You just see some videos on the internet. It's super cool the way they display the characters and how you move around. And anyway, it was the first one, also because we're using a modem, not the internet directly. That means that you have to dial up, and while you're playing, other people cannot call you home. So it was strange, but still, it was cool. And I think this is the one I want to use as a reference for what we want to do for the second assignment, because it's simple, it works well, and we can use something like that. There's other ones that's more famous, Habbo, where it was in isometric style, and well, there was a lot of cool things in Habbo, like you can construct your own places, and you can invite people to your house and stuff like that. And also Second Life, it was peer-to-peer. No, you have to connect to a server. Habitat, there was main servers, and you call to the main servers, and they did the connection between all the people. So it was not like a one-to-one application. This was like a regular group, like, I don't know, like a MMO, something like that, like where you join, and there's a lot of other people that you don't know there. And from there we go to Second Life, which was the first attempt to do something in 3D, like a virtual space. You probably were very young when Second Life appeared, but I remember it very well because it was after when I was studying the career, and everybody was crazy about Second Life in the sense that they thought something similar to what happens now with the metaverse and other things like happened before, like with cryptocurrencies. Like everybody thought this is the future. Everybody has to be here. If you are not here, if you're a company and you are not in Second Life, you are getting behind. So there was a lot of companies investing millions of dollars on Second Life because they thought that the internet was going to be Second Life. Like everybody was going to be on Second Life in the future, so you have to be there. And it was a failure. Okay, nobody wanted to be there because it was ugly. It didn't work well as a space to interact with people. It was very open to creativity. You could program your own application inside Second Life to make interactive things. So it was cool, but there are still people using it. But it was a failure in the sense that none of the things that people say what were going to happen on Second Life never happened. So it's nice to see that sometimes there's always somebody who comes and says the future is this, and yes, they say this because they want to earn money about that. But the truth is, unless people love that platform, you are not going to make the future from there. I like to put here Gary's mod. This is a video game. For those of you who don't know, it's a game that was a mod for Half-Life 2. And one of the nice things about Gary's mod is that the creator, Gary, he decided, which by the way, Gary is the creator of also the very famous game Rust. He decided to make a system for letting the people program anything on top of the game. And that opened the possibility to construct very strange video games created by people using this mod. And that created communities where people were doing crazy role playing and using it to socialize with rules. And I don't know, it was a crazy kind of environment because from a game they constructed a community of people, and all they can share their own servers with their own rules. So it was a very powerful, and there was a moment where it was a peak. I think that was like the number of players on Steam was one of the highest, was playing Gary's mod at the end of the 2000s. And there has been more commercial things like PS Home, the approach from Sony to make that came with the PlayStation 3, I think, where you were supposed to be able to walk around your own house and it was all very fancy and you can buy some clothes. It didn't catch on because there was not much else to do. I also put here Minecraft because Minecraft has been huge as a space for people to interact. Roblox, and more modern things are like VR chat because this is the current state of virtual space where everybody can interact with other people. Okay. So it's nice to have references when we think about these kind of approaches because otherwise we wouldn't think that we are doing something new. What this has been done for more than 40 years. Okay. So, and also with now with the telepresence thingy, now with after the pandemic, everybody is always thinking about can we enhance the way we communicate with people when they are at home and they have to interact. So that's why I've been pushing a lot all the concept about presence. Okay. And also because we have all these technologies, Unreal, web, VR, and I don't know, all engines and everything, it's kind of easy to construct a VR platform for people to interact with. But still, we are missing the real important thing, which is, do we really need these kind of solutions, or we can just go around with the things we have already? Okay. So, this is, I will continue this presentation next day, but for now I want to talk more about how can we construct our own virtual space. So for that we're going to need two things. We're going to need to render or to draw here a room, something that looks like a space. It doesn't have to be any fancy, it could be just an image. And we're going to need to render here something that looks like a person. And we're going to use that person as a way to embody ourselves on this chat. Okay, so let's start by the first thing that you should always do when you have to think how to construct something is you have to construct what I called on the slides. Let me go 1 second. Yes, this. Okay, we need to have a scene state. Okay, and this is very important. This is something that most of you miss. You start coding the final part of the application, which is how you draw something. But the first thing you always think is, what should I draw? And what you should draw is something that has to be stored in memory. Okay, so for instance, if I say you have to draw a background image, the most common approach you would use, and it's wrong, is going to be something like this. So you're going to go to your code. I'm going to remove now this square for now. Okay, and you're going to say, okay, I have to render an image. Do I have that image? Yes, you have it. I have here an image. I'm going to show it to you that looks like a room. Okay, I have downloaded from the internet. I don't know if it's from a video game or what, but it's good enough. It's the resolution. It's not very big. It's also pixel art. So I like to use pixel art because the images are smaller, so they load faster, and you have to edit it. It's less pixels that you have to edit, so it's always better. And this image is not like a pixel art image that has been stretched. This is an important thing that you always should keep in mind. Let me show you something. If I take this image here, and I'm going to open it on Photoshop, you can see that this image, every pixel, it's 1 pixel. So if I select here, you can see that it's 1 pixel. So it's not stretched. Okay, be careful with that because most of the images you will find on the internet, they are pixel art, but because they look very tiny, if you open them like this, they usually have scaled the images by 4 times, and if you scale the images 4 times, it's going to have more pixels that don't bring anything on the table. So it's always nice to have a smaller image that you know it has the right size. Okay, so this image, I have it in the same folder. So if I want to render this image, it should be as simple as going here and saying draw image, and I have my get image function I did yesterday, and this image is called, sorry, background PNG. Okay, and I want to draw it on position 0, 0. Okay, so now I have the image drawn. Okay, and I don't forget anything. Okay, you can see that I call the function directly from here. I don't have to store the function in an object and an image EMG and call it again. There's no need to do that. So if I go back to my code and reload it, and it's not working. 1 second. The console says cannot read property of undefined. What? 1 second. I probably did some error on my code. It says EMG's URL. Okay, and the function is called EMGs. So what? I'm doing something wrong. 1 second again. So it goes to here, and this is undefined. But it's defined over here. What? Let me check again the code. Something weird is going on. I copied the code before. Probably I moved something and I destroyed something. So these EMGs, I'm going to put it here. I think it was problem of the order because probably was calling, yes, it was calling the loop, and the loop was calling draw, and this EMGs wasn't defined yet. Be careful, because if it's not the same to put the variable here that to put it here, because if you put it here, when you call this function, this variable doesn't exist yet. Yeah, so that's way better. I reload, and I have my image here on the top. Okay. So, well, it looks small. There's many things I can do if I don't want it to be small. One thing I could do is to go to my app, is to change the size here. If I know the size of this image, if I say, no, this has to be 400 by 300 pixels, or I don't know, 600 by 400, I can do that. I'm going to resize the image, but because I'm resizing the image, it's going to look more blurry because it's going to try to do a bilinear interpolation of the pixels, and that's not something I like. If you don't want to apply the bilinear interpolation, there is something you can do, which is you can specify that image smoothing enable equals false. This is on the slides, by the way. So if I do this now, you cannot see, but now it's not so blurry, the pixels, because, well, it's trying to don't use bilinear interpolation if you don't want to. But still, every time you draw, you have to take into account this image has different size. Also, I'm drawing from this corner, so I have like half of my screen is empty. So as I said the other day, it makes more sense that we start thinking more smartly. So first, I'm going to save the coordinate system, and I'm going to move to the center. So now the 0, 0 is here, okay, which is way better. And now if I had to draw an image like this one, I can say, I don't know, minus 100, something like that. So it's more centered. I don't know, the size, the image is like, sorry, 200. And so that now the image is centered. And now if I by any reasons I resize this object, it's always going to be on the center. Oops, sorry. It's always going to be centered. So it is way better than what we had before, okay? But we still have the problem of the size, and because I have scaled the image, that's not kind of clean. So still it's kind of a strange way of working, and as I'm hard coding things here like numbers and URLs. So that's not the way you should do the things. If you want to have a background here, you have to first ask yourself, why do I want to have a background? And it's because you want to represent a room. But if you want to represent a room, then you need to have some sort of data representation of that room. So in this case, let's go back here to my application, and maybe here we can have something like says my wall has rooms. Okay, now we have a wall that has rooms, and maybe I want to have a function to create room. Okay, we can give a room a name, maybe a background. Okay, so when somebody calls this function to create a room, you have to specify the name of the room and some address. Okay, so what it's going to do is going to create an object, and this object is going to have, as name is going to have name, as URL is going to have the URL. Okay, finally it's going to return this object in case that you want to do anything else. But what most important is going to go to rooms, and is going to store the room here. Okay, so now this container here contains all the rooms I have created. Sometimes I like to also do this, rooms by ID. Okay, because sometimes I want to fetch a room by the name, not by the position on this array. So I'm going to have two containers storing the same rooms, but this is going to be an array in case I want to iterate very fast. Or I can use this room by ID, where I can just search by ID. If I didn't want to use an array, I can just remove this if I want to, and just use rooms like an object here. And instead of doing push, I can do something like this. I'm going to say the name is equal to this room. Okay. The only problem of doing this is if I want to know how many rooms I have, I cannot. And also if I want to have an index to go to a room, like specifically, I have to use always a string. But still, this way, if I can create rooms very easily, they're going to be stored here. And I like also always when I do these kind of things to have an ID. So in this case, every room should have an ID. So I'm going to say that the ID of the room, besides the name, which is an ID, I also going to have this last ID. So every room I create is going to have a new ID. Okay, this could be handy if you want to use numbers instead of strings. Anyway, I have now somewhere to store rooms. Let's create some rooms. I go here now and say, hey, well, create me a room that is going to be, call it the hall, and is going to use this background, background PNG. Okay, that's it. And I can create another room if I wanted to, like, I don't know, street with another image. I have two images, by the way. You will see later. So now I have two rooms created. And now the next thing I want to is to have a way to specify which room I want to draw. Currently, I can have many rooms, but maybe I need to say, no, I want to render the room, I don't know, hall or street. So for that, maybe we can have something like current room that by default is null. But when I create the room, I'm going to say that set up current room as the first room I create, the hall. Okay, so this variable, so when I create the room, is going to return this object here, and I'm going to store it here also. So in any moment, if I need to access the current room, I have it here. This current room is the room I'm watching now on the screen. Okay, the one where it's supposed to be myself inside. Cool. So now maybe I want to make more functions here, like draw room. So I'm going to pass here the canvas, the CTX, and the room. So this function is going to draw me the room. So once I have translated to the center of the screen, instead of doing this, I'm going to call this function draw room, and I'm going to pass here the canvas, the context, and the room itself, which is current room. Okay, and I can do something like, but to just some error control. If there is no current room, there is nothing to draw. Okay, in this case, if by any reasons I remove the current room, it's okay. It's not going to crash my application. Okay, so now I have the room. If I had to draw it, I'm going to say, go get me the image of the room, like URL, for instance. Okay, and where I want to draw it, I'm going to store here maybe as an image here. Okay, and maybe I want to center it in the center of the screen, so I'm going to say the image width divided by 2, but negative. So that means I'm going to go, remember that when you draw, well, if I didn't put this, if I just put here 0, 0, it's going to draw on the center of the screen. Sorry, there's an error here. URL can read null or read. Also, this variable is null. Let's see why it's null. Go here. Room is null because probably the room wasn't never created. This function is never called. Yep, this function is never called. That's weird. I thought I could call it from the code, maybe at the very bottom. Oh, but I started the application way before anything exists. So if I reload here, it doesn't reach here. It reaches first here, but room is supposed. If this, no, sorry, I put if no current room. Sorry, I made the mistake here. If there is a room, okay. I reload again. Okay, now it goes here. Cool. I don't see anything. Let's investigate why. Last ID is not defined. You're right. I forgot to put the last ID here. It is this. Okay, so I have a room here, but the 0, 0 is here. I want to center it, so the way to center it is always subtract the width and half of the width and half of the height. And so I'm going to go here to my app. I'm going to say that when you draw the room, maybe use the width divided by 2 in negative, and the height divided by 2 also negative. So if I do this, now it's centered, but still just very small. So as I said, I have two options, or I have a scaling function here, okay, scale, and I'm only going to scale this image. I'm not going to scale anything else, but that could be a problem if I have more images that are also small. So it would be better to scale everything, because I can have something like this, like draw this image, but this image width multiplied by the scale, and this image height multiplied by scale. So now it's going to be the same, but if for any reason I change this number to 4, it's going to be 4 times bigger. Also, I should also multiply the scale by by the image width here, and also by the image height here. So okay, but I don't like to do it this way. I'm going to leave it as one, because if you do that, if you draw something else, it's going to also be very small. So it would be better to just scale everything. And because we are already applying a transformation on our system to translate to that position, I should also do the I can do the same and say, hey, I want everything to be 4 times bigger, okay? 4 times bigger in X, and 4 times bigger, and by the way, I forgot to put here restore, to go back. When you save the current state, always remember to restore it at the end, okay? So if I do this now, I reload, it's 4 times bigger, but the nice thing is that everything I draw is going to be 4 times bigger. So now this is not the position minus, I don't know, the width of my screen is probably 2000 pixels. So this is not minus 1000, it's minus 250, okay? The problem is I have modified now the coordinate system, and that could be problematic, because now if I want to know if my mouse is on top of this door or is on top of the floor, because I have to scale everything, my mouse position doesn't are not right with the position. So we will try to fix that later when we go to the mouse position, but that could be a problem. Okay. Now I see your message, Ainhoa. Thank you for realizing I didn't saw it. Cool. So we keep going. Now we need a character to draw on this space. And if we go here I explain on the slides, it's around here on the last slide, that I'm going to use this character that I created some time ago. We are using this on the course for many years because, well, creating characters is always complicated with you how to draw frame by frame, and there's many images like this. This is called sprite sheets, and if you search on the internet, there's websites where they have sprite sheets of every single game that uses sprites, like, I don't know, Super Mario's and stuff like that. But the problem with the sprite sheets is that they usually don't have the sprites aligned. Like here, every sprite here has the same size, and having the same size has a lot of perks, as you will see now. So I'm going to download this image, and to get this image, if I click here, it's going to download it, I guess. Yep, but I don't have it yet. 1 second. Let me see if I can find the file on the downloads file. Nope, it didn't download it. Anyway, I'm going to go to this link because it's going to be easier. So this is an application I did some time ago where you can configure the character. When you press a space, downloads the image here. So I'm going to put the image on the ECB here. It's going to be, I don't know, character1.png. I'm going to create a new one. You can change, no, this is the animation. No, what it was, yes, the face. Let's change, no, yeah, the face like this. So I'm going to have here and have another image here. I'm going to say character2. Okay. So now I have 2 images. I want to see if I can draw one of them here. Okay. First of all, keep in mind, as I was saying before, that this image is a sprite sheet. Let me show you the sprite sheet so you understand how it works. So this image contains, first you have the background is transparent, as you can see. So that means that I can overlap very easily with any application. And the next thing you have here is that every single character has the same size, which I think is 64 pixels by 32, if I recall correctly. Yep, I think it's like this. Yeah. So I'm going to put here these 2 lines so you can see it. Okay, so the nice thing is if I want to animate, I only have to jump a fixed amount of pixels to the left, to the right, if I want to animate the character, okay? But let's start by drawing the first frame. And so for that, I'm going to go to my application again. And obviously, I don't have, as I said, I can go directly here and start drawing, but I don't want to do that. First, data. I have to have a definition of this data. So maybe when I create a room, I can say something like people, to say who is in the room, and then I can store here the people who is in this room, and that way I always can have a data representation of the people. And in this case, I don't have a way to construct people, so let's say, I don't know, user, maybe function user. I'm going to create a character. I call it user, could be participant, player, whatever you want to. So it's going to have a position. For now, position is going to be just one number. because not like a two numbers. It's not going to be X and Y because people only are going to move left to right. So I only need one. And also avatar ID, which is going to be which image I'm going to use for the character. In this case, like the image I created was the character 1. And I don't know. We can have also a name maybe. For now. Okay. So besides creating the room, and also it would be nice to have something like to which room it is, like a double link to see which room is started. But for now, let's create a user. Okay, and say that this user is in one room. To make the user is in the room, I can do it manually, but I'm going to make it a little bit more beautiful. So I'm going to have a class called room, maybe. By the way, I don't know why I'm using caps, because for classes it's always better to do it like this. So a room is going always to have this kind of properties. It's going to have an ID, which by default we're going to set it to -1. And we're going to have also a name, but maybe the name you can pass it like here. I don't know. And it's going to have the URL by default is going to be null. And damn it. And finally, who is inside this room? People. Okay. So now instead of creating this object like this, I'm going to make it more clean, which I'm going to say new room name, and also now room ID equals to this. So this is a little bit better because you have an object of type room, so that makes more sense. The name I don't need it because I already passed it, and the URL. Okay, and the people I don't need it. Okay, because I already. So now every time I create a room, it's going to create this object room. It's going to attach it, and it's going to also create the people who is inside the room. Okay, cool. So now I create a user, and I go to this room, and I say on people, push me this user. Okay. Maybe to make it a little bit more clean, we can call a function. So instead of accessing directly the properties, it's always better that you create functions. So remember, in JavaScript, you do this prototype thingy and add user. And we're going to pass a user here. So if I want to add somebody here, it's going to go to these people, and it's going to add this user here. And also, this is a good practice to say this user is in the room, in this room. Okay, so when I go here and I say I want to add somebody, I have this user, and I'm going to say current room add user, and I'm going to pass this user. Okay, so as you see, we are focused on the data now. Okay, why using function here instead of class? Yeah, you can use function or class. Functions and class are exactly the same in JavaScript. This is just at the beginning to make classes, we use this syntax. Now they change it to classes, but you still can use this syntax. I prefer to use this syntax because it's the one I started with. But if you feel more confident using the word class and using the structure of class, go ahead. It's exactly the same. Okay, so now we have at least one user on the room, but we need to have a representation of that user. So when you draw the room, maybe it makes sense to iterate through all the people in the room, and for every one of them, we're going to render this. So I'm going to go have a function here, call it draw character or user maybe. Yeah, user. I'm going to pass the canvas and the CTX and the user. Okay. The user will be this user. Okay, so now we make another function, draw user, that receives. Really, I don't need to pass the canvas all the time. If I don't want to, it's not need to. So I'm going to remove this because it doesn't make any sense to use this. Because the canvas, if I need the canvas, it's already in the context, so I can use the context if I need it. So when you call this function, I'm going to pass the canvas. Okay, so for canvas. So now I have the context. I draw the room. So draw room background and draw room users. So I'm going to draw this user, and so I go here. How can I draw this user? Well, I'm going to draw an image, which is going to be this image here. In which position? Sorry, I forgot to put here the user. Well, in user position on X and in 0 on Y. If we have to adjust this number, we will adjust it later. And now we need the image, so we can use or get image. And for the user doesn't store the address of the person now, but maybe we can do it. So avatar. I'm going to do it like this: character one.png. Okay. So I'm going to get the image user avatar. If there is a user avatar, if this user doesn't have avatar, there's nothing to draw. Doesn't make any sense. I'm going to get the avatar and I'm going to draw it in position 0 and X. Okay. So let's reload to see how far we went. Boom. We have the character. Well, many things to point out here. First is drawing all the image, the full image with all the frames, which doesn't make much sense, but we're going to fix that now. Also, we can see that it's using the 0, 0 of the position is here, and because it draws from the corner, it's drawing a little bit offset. Maybe it would be nice to draw it here. So we would just apply for every one of those things our own solutions. Let's start by drawing just the first frame of the whole image. The function draw image has many versions of the image, of the function of the parameters. There's like what is called overloaded function. And the idea is that if you specify here the size, I don't know, like 50 by 50 pixels, it's going to draw the image compressed in 50 by 50 pixels. But, and this is something interesting, you can specify if you want to, let me show you. You can specify on the function to draw, you want to draw this area of the image from here to here, not the full image, and then you say where you want to draw this area. Okay, so to do that, you have to specify here first which area do you want to draw from the original image. So the area I want to draw is from 0, 0 to 32 by 64. Okay, and now you have to specify where you want to draw it. I'm going to draw it, as I said before, in user position 0, and it's going to have the same size, so 32 by 64. Okay, if you do that, you can see that it's going to only render that area of the image, not the full image, just the area that you specify. Okay, if by any reasons I did something wrong and I specified wrong the area, for instance, like, I don't know, I put here, you can see I'm rendering half of the person and half of the next frame. Okay, so now you can see that this allows me to cut the image on one part. Okay. Why is this useful? Because now if I play with this number, if instead of using 0, I put 32, I'm going to move the area I draw, I'm going to move it to the right. I'm going to draw this next one. Okay, you can see if I go 2 times, so 64. So if I put here 64 and I reload the image, it's going to draw this other frame. Cool. So now we have a way to switch between frames. So let's try to see if we can do something like, if we have a frame ID, we multiply it by 32, and then we know which frame to draw. So if frame ID is 0, it's going to render the first frame, okay? But if frame ID is 3, it's going to render another frame. And here's where comes the magic. If by any reasons I start animating this number, so for that purpose, I can have, I don't know, some variable with the time. For time, performance now, multiply it by 0001 because it's in milliseconds. I want it in seconds. So I'm going to use time here. So every second is going to advance to the next frame. If I reload this, you can see that, this number here has time, has decimals. If you multiply this in milliseconds, you multiply by 0001, it's going to be, I don't know, 1.001, 1.002. Okay, but we want the frame to be a round number, an integer number. So what I'm going to do here is I'm going to say that remove the decimals. If I remove the decimals, it's going to be 0. After a while, it's going to be 1. After a while, it's going to be 2. Okay, so now if I do this, you can see that 0, 1, 2, 3, 4, 5, and it's going to move. If I want to speed up this, I can just say 15 frames per second, and it's going to move. The problem is that as soon as it finishes on the list of, I mean, it keeps moving to the right of the image, there's no more pixels, so you don't see. So you only see it once, and it disappears, okay? But we can fix that very easily. Let's going to create something here, a new container called animations, okay? And these animations, we're going to make a group. For instance, if we're idle, we're not doing anything, we're going to use the animation number 0. But if, sorry, the frame number 0. But if we're walking, we're going to use the frame number, let's go here. It's going to be for walking, this is 0, 1. So it's going to be 2, 3, 4, 5, 6, 7, 8, 9, okay? So it's going to be 2, 3, 4, 5, 6, 7, 8, 9, I think. Okay. And also if we are talking, as this is 0 and 1, I think it's like talking. Okay, so how we have this sequence of frames, okay, that we can use if we want to make an animation. So imagine that I want to animate the character walking. So I go to animations, and I get animation of walking. So now I have this array here that has all the frames. So now instead of just using the time to define the time that says which frame, I'm going to use the time to pick up one of these frames from the array. And if I'm outside of this array, I'm going to go again and do the module. So it's going always to go back again. So if I on the next one, it's going to enter on the other side and get the frame again. Okay. So to do that is very easy. You just have here a number that's always going to increase. Remember that this number, in case that you want to see it, it's a number that is always going to increase. If I show it to you here, you can see every second is going to increase this number. Well, now it's increasing a lot because I multiplied it by some factor to go faster. But I can say now, instead of taking the frame directly, go to the anim and get that frame from here. But the problem is that if I do this, it's going to start with 0, 1, 2, 3, so it's going to take 2, 3, 4, 5. But when it's almost at the end of this place and tries to fetch another frame, it's going to get out. So in these cases, you always use the module to be sure that this number can never get as big as another value. And we specify here the number of frames. For those of you who don't remember how the module works in programming, in any programming language, remember how it works. You have a number, like I don't know, 20, and you do the module by 10, sorry, by 3, a module of 3. So let me show you. I don't know if you can see it. You have this number 3, and I divide it by module of 0. Well, it's not possible, but by 1 is going to say, sorry, I have the number 1, and I say module like 3 is going to be 1. If I go to 2, it's going to be 2. But if I go to 3, it's going to be 0. If I go to 4, it's going to be 1 again. 5. So you can see that the number always stays inside 0, 1, and 2, because this is the rest, the residue or the rest of the division. Okay, so we can take advantage of this and say, oh, then what's easier is just we have a number that's always increasing, but we're going to be sure that this number is never bigger than this. And if this is the case, it's going to start again from the other side of the array. So just by doing this, I reload again, and I have a walking character. Okay. And it's quite simple, this approach, because it's, well, you have to work with animations. This is the simple way I always found. People who have made the course of video games, we use the same approach to make animations on the video games. So, cool. Now I have a way to animate the character. And the nice thing is if I want to change in any moment the animation, I can. I can say, no, I want you to be talking, not walking. So he was going to be talking. And I have more animations here, like sitting, and well, that's mostly it. Okay, but more things we may need. Another thing we may need is maybe we want to have the character facing in different directions. So how can we do that? The nice thing about this sprite sheet I created is that I put the same frames facing forward, left, and backwards. Okay, so it's very easy if you in any moment wants to change the character to face in another direction. Instead of having to do very complex computations, you only have to, on this frame, go to the next line. So instead of here, where we were always taking the first row, this number 0, is we pick it from this corner always to the right. So this frame, if I just jump 32, it's going to start from here. So let's do a test. Instead of 0 here, I'm going to jump 32 pixels below. And if I reload again the website, you see that, sorry, it's not 32, it's 64, because the image is 64. You can see that now it's facing in this direction, okay? So one way to make this a little bit better is say here facing, multiply it by 32, and facing, we can have maybe some globals. I like to have globals always. So we can say facing right is going to be 0. Facing front is going to be 1. Facing left is going to be 2. And facing back is going to be 3. Okay, so every user now will have also a facing. So by default, it's going to always face front. Okay, makes more sense. So by having this facing now, when I'm going to draw this character, I can say, hey, depending on the facing is going to be the user facing. Okay, remember this number could be 0, 1, 2, or 3, and because we are multiplying by 64. Sorry, 64. Now, if the character is facing left, it's going to move 64 pixels down. Okay, so let's try to see if it works. It's facing the right direction, but if I go here, I search for this user. Let me see if I can find this user on the memory. It's easy because I have it on my app. I didn't store it. Yeah, no, it's not easy because I forgot to store when you create this user. I created it, but I didn't store it. So I'm going to go like this, my user. Okay, so now if I go back here, reload, and I have here my app dot my user, I can say, hey, facing, I want that you are facing left, and he's facing left. Or if I want to face right, and he's facing right, or I want to the back, and he's facing to the back. Okay, so and also we can control. Finally, the last thing we can, if we have the facing, we can also have the animation. By default, it's going to be idle, but we can come here and say that when you have to take the animation from animations, take the one that is in user animation. Okay, so now the character itself is defining his animation. So now you can see he's stopped because he's using the idle animation. But if I go to this character and I say the animation has to be walking, he's going to start walking. Okay, because I'm using indirection. This is something that's important when you program, is to use a lot of, you get used when you are better programmer to use a lot of indirection. So I'm not storing the frames that he's using here, which I could do, but it makes more sense that I use an ID of some data I have somewhere. And in this case, this data is stored here on the application itself. When I have to draw, these are the animations. By the way, it's always good to have, if this animation doesn't exist, return. Okay, this is important because by any reason, maybe you have an animation on the user that doesn't make any sense and you don't want to crash the application. Okay, so cool. Now we have a way to have a character. He's stopped. He's not doing now unless we interact with we have to decide how we interact with this character. I know that the most simple solution could be that we have used the cursor keys to move this character around. I always discourage the people to use the cursor keys. If you use the cursor keys, if you want to use this application on a tablet or a cell phone, it won't work. And it's nice that you have the freedom to use this application even in any device. And so I would recommend, and I will not recommend, no, and one of the requests for the second assignment is that you have to be sure that this character is going to move using the mouse. So if I click here, I want the character to be here. But we have many problems here. First problem is that we are drawing the character on 0, 0, and we are drawing in this. So maybe instead of drawing in 0, 0, I want to move it a little bit down. I know that this image, the image we are using for the background, this over here, okay, it's I think it's 100 pixels big. So this image in total is 103 pixels. So this pixel here should be the pixel, I don't know, 100 or 90, 80 probably from here, but because we are centering and was a little bit more complicated, but anyway, we are going to do trial error. So in this case, I'm going to say that first, when you draw the character, don't draw it just in the position. I'm going to subtract 16 pixels. So that means, by the way, I'm going to draw on the center of the screen something, so it's easy for us to understand where is exactly the center. So on the center of the screen, so the origin, the 0, 0, and 4 by 4 pixels. Okay, so field style is going to be red. So at least we know the center where it is. Okay, so if we go to here, the center is here. So I have moved the character a little bit like, and exactly the center is here in this corner. I'm going to also make that is, instead of being like this, it's going to be -1, -1, 2, 2. So this is exactly the center. Okay, so I have, when I'm drawing the character, because he's 32 pixels wide, what I'm doing here is I'm moving him 16 pixels to the left, so at least it's centered vertically. But about for putting here, I'm going to just go and say that I don't know, maybe -20 pixels, a little bit more, minus 25 pixels. Okay, so we have now a character. I'm going to move it a little bit down because that feels a little bit closer to the camera. Yeah. Okay, so now we have the character and we can move it quite easily. Remember that we can go here and say position is 10, so it's going to be on the position 10 or 30, and we can change anything. And animation equals walking, and facing equals facing, no, back now, left. Okay, so you can see now that what I've done is I have created first a data representation, which is very easy to manipulate. I can manipulate the position, where it's facing, the animation, and even the character if I wanted to. I didn't do it, but if I want in any moment to change the character, so that should be super easy. I go here and I say, hey, your avatar is now character2.png, and boom, it got changed. Okay, so this is always the idea when you work with any application. Okay, please think always in data. Don't think on algorithms, don't think on code, don't think on functions. Think on data. You have to have a mental representation of what's the data, and then you have to transform that information on the screen. Okay, so let's go back to the slides. Now we have something that looks more interesting. What else we can do here? By the way, to render the animation, if you don't want to waste too much time copying the code from this video, here is the full code. You can see here that I have a function that you specify which image, which frame, where do you want to draw it, and the scale in case you want to change the scale. And also, I didn't say, but you can flip it. I put here the option to flip it. But if you don't want to, don't have to use it, because the image, there's already the image flipped on this style sheet. But most video games, they use the same, like when they have this image to the right, they flip it horizontally, the image, so they have that one. So you save some space between, you don't have to store right and left. I just did it because it's much easier from the coin point of view, and also maybe because you can have a character that on the left side has something and the right side doesn't have it, so it's maybe nicer to do it this way. Cool. So, how much time is left? Well, it's 30 minutes. So the last part I want to talk about is, can we easily control when you click the mouse to know where has the user clicked the mouse? So let's imagine that I'm going to add here some bar. I don't know. Let's call it target. Okay. It's going to be just a number. And when I draw the character, I'm going to draw a line. Remember, this is for drawing lines that goes from the position of what is the player. The player is supposed to be in this position. No, this is the corner. This is the position on X, and the position on 0. This is where it is, and it's going to draw a line 2 to the user target 0. I'm going to use two numbers here just to explain something because it could be useful for you. So to align to one position, in this case, it's always going to be 0, 0 position. Okay. If I do this now, we don't see anything. I'm going to go here, say that CTX stroke style is going to be white, so we can see it better. Okay, we don't see anything because he's centered now, but if I move the person a little bit to the right, as I did before, you can see that this is the center of the character, the 0, 0, and this is the target position. In this case, it's 0, 0. Cool. So what I want to do now, I want to control this position with the mouse, this point. So when I click, I want this position to be in that place, okay? That should be fair simple. I go to my function here and I say on mouse down. Remember that this function is being called automatically every time we click the mouse. Okay, so I say when you click the mouse, go to my user and to the position, sorry, to the target, and I'm going to use the target 0 is going to be the mouse pos 0, and for the target other one is going to be mouse position 1. Okay, remember this mouse position is this global variable I created here, mouse pos, and I update this variable always before I do anything calling this on mouse. So this always is going to be updated. Okay, so if I do this, you can see that if I click, nothing is happening now. 1 second to be sure I'm not messing around with the function. So I click here. So it's going here in this function and on mouse. What? I didn't reload it? Where did I draw the function then? What? I didn't save it maybe? Yeah, I didn't save it, I think. And again. No, yes, sorry, this code wasn't here. So if I click now, you can see that it doesn't make any sense. You can see that, oh, I'm clicking here, but this coordinate is not here. I'm drawing something. What's going on here? Remember that the mouse coordinates, they come like from 0, 0 here. So it's giving me the coordinate, I don't know, probably 500 by 500 pixels. But this coordinate system of my render, when I draw the scene, is totally different for many reasons. First is because I have applied an offset. I'm offsetting everything to the center of the screen. And secondly, because I'm scaling it, I'm making it bigger. So that has an effect on the coordinate, because that's not going to be the same. This is very important. Always, when you manipulate the system, the coordinate system, keep in mind that I have two coordinate systems now. I have the coordinate system of the mouse, which is the 0, 0, is here in the corner. But I have also another coordinate system, which is the coordinate system of my game or my wall, where the 0, 0 is here and the 100 pixels is here, when in reality this is 400 pixels. Okay, so let's start by doing the simple thing. Is I'm going to not modify the coordinate system, so I'm going to remove this translation and this scale. Okay, so my coordinate system is going to be the same. The canvas and the mouse are going to have the same coordinate system. If I reload now, I can see if I click, yes, this makes sense. Is drawing the line exactly where I'm clicking. Okay, but as soon as I add this code here, just to center it, it's not working because I'm offsetting the drawing, but when I read the mouse, this is not offsetted. So it's kind of common to do is when you make an application, it's good always to have these two functions I put here on the slides. Where did I put them? The coordinate systems, local coordinates. This function, wall to canvas and canvas to wall. These two functions, the idea of these two functions is you can convert always from one coordinate system to another one. So let's do this function. You don't have to copy it here because it depends on how you have applied transformations. So let's do it here. Imagine I want a function here to transform. So I'm going to say here from canvas coordinates, which is the mouse coordinates, comes in canvas coordinates, to wall coordinates. So I'm going to pass a position here. So any transformation I have applied to anything I draw, I have to apply also to these coordinates. So I'm going to return another coordinate, which is going to be the position 0 and the position 1, the same values, but applying the transformation. Which transformation? Well, first, I'm translating everything here to the right half of the width and half of the height. Okay. Okay, maybe I can store here something like offset No, I'm going to just use that directly. It's going to be simpler. So I'm going to go here and say, then to the post 0, I'm adding this translation. Okay, so I'm going to add here this translation. And to the number 1, I'm also adding this translation. So I'm going to do the same here. So, oops, I'm going to copy this and put it here. Okay, so now instead of using directly the mouse coordinates, if in any moment I need to use the mouse coordinate for something related to the wall, if I was using the mouse coordinate to something like clicking on a button here or detecting if the mouse is in the left corner of the screen or something, then it's fine. I can use the canvas coordinates. But because I want the mouse to click on things on my 3D, on my 2D wall, in this case of my game, I need to be sure that I have transformed the coordinate to the other space. And to do that, in this case, I just apply the same transformation. So let's check if this works now. I reload here and I click, and it's not working yet because I didn't use this function. So now when I use the mouse here, instead of using this, I'm going to local mouse is going to be transform the mouse position to the local coordinates of my rendering, of my drawing. And I'm going to use this local mouse on as the target. Okay, so now if I reload again, I click, it's not working well, probably because I did the opposite. Let's check again. 1 second. Yeah, sorry, because I'm translating everything to the right, I have to apply the opposite thing to my mouse because I want to transform on the opposite. So I did wrong. It should be negative value. Sorry, you have to do the opposite transformation. So here now, if I click, you can see that now it works. Okay, cool. So now I have a system to control when I click in which wall coordinate do I have clicked. Okay. The next thing is taking also into account the scale, because if I add the scale now again, you can see that the coordinate is not going to match. Okay, and the reason is because you can see something interesting, which is that when I click, it's in the same direction. It's just because I have to scale this value. Okay, easy. In this case, I'm multiplying the coordinates. Everything I draw in, I'm multiplying its size by 4. So it makes sense then that when I transform this, I'm going to divide everything by 4 in this case. Okay, so I'm going to take everything here and divide it by 4. If I do this now, you can see that when I click, I have the true position of this. And this is important because I may want to control if I'm clicking on a character, on an object, on a door, and if I have the coordinates inside my space, if I know, for instance, let's do something. I'm going to no, I wanted to have more interesting room, but anyway. So maybe I can have something like, say that if the character is in front of this door, there's an exit and he can exit the room. So first I'm going to make him move. That makes more sense. So now what I'm going to do that every time you click, I'm going to take the X coordinate of the click on the position. I'm going to move the person to this position. So every time you click, instead of modifying the target, I'm going to go to my user and say, hey, your position is going to be the local mouse X. If I do this, when I click, I'm going to move the person to wherever I want to. Yeah, but this doesn't look very nice. It's a little bit strange. So next step should be, can we make him walk to this position? Sure. How can we do that? Well, we want to modify the state of the application constantly. And remember, the function that should modify the state is always the update. So what I'm going to do here is I'm going to go to my user. Okay. And I'm going to say that the position, I want to increment it by a delta. Okay. This delta is how much he should walk every time. How we compute this delta? This delta should be, first, the difference between where he's now and where he wants to be. And that's why we have the target. So I can go to my user. I can get his target 0 is where he wants to go, but I can subtract it by where he is now. So my user position. So if we subtract destination minus current position, we get the offset. Okay, how much should I walk? Okay, but obviously he cannot walk a lot. I mean, we expect him that he has he cannot walk an amount. Let's say, I don't know, 10 pixels per second. I don't know. So if delta, if the absolute value of delta is bigger than, if delta is bigger than 10 pixels per that we want to move, then it's going to stay, delta is going to be 10. Else, if delta is smaller than -10, delta is going to be -10. Otherwise, it will just keep the same value. And finally, to move something, we always should add the time. So now we compute how far it is, and based on how far it is, we're going to move an amount on that direction. Let's see how it works. I reload. It's crashing. Let's see why it's crashing. It's talking about user target 0, and he doesn't like that. Why is not target? When you go reload again, and my user, no, my user doesn't exist yet. Sorry, yes, sometimes my user doesn't exist because I haven't created yet. So if this my user, we can do this. Okay, so I click here, and he's going to move in that direction. Okay, if I click here, he's going to move in that direction. Cool, maybe 10 was not enough, maybe 30 would have been a little bit better. Let's check now. Yeah, this looks better. Okay, and what about animation? Can we control that? Yes, we can say something like if delta is equal to 0, so we can say that he has, by the way, I didn't saw it, yeah, I was expecting this problem. Let's see this. You can see that when he's getting closer and closer and closer, it's like he never reaches the position. He gets closer and closer, but it's super slow, super slow, super slow. I'm going to do something. If it's bigger than 0, it's going to be 30. If it's smaller than 0, it's going to be -30. Otherwise, it's going to be 0. Okay. Because I don't want him to walk faster or slower depending on the distance. If he's very close, he's going to walk very, very slow. That doesn't make any sense. So now he's going to go, and when he reaches it, he's going to stop. But it's going to happen this is a very common problem. I don't know if you can see that he's shaking. The reason why he's shaking is because he's the distance is -30, so he's adding 30, but then it has passed the position, so he has to go back and forth and back and forth. So you can say if in any moment the distance is if we know that he's almost there, like if this is the difference, sorry. Okay, if the difference in absolute value is smaller than, I don't know, 10 pixels, then we just say, okay, you have reached the place. So this user position is going to be whatever we want it to go. So it's not going to try to pass across. We just assign it and fuck it. Otherwise, yes, otherwise we're trying to reach it. So now we go to a place, and when it's too close, boom. Maybe I put it too much, 1 pixel. If it's 1 pixel away, pop, he sticks to that place. Cool. Finally, we have also another thing. If we have a delta, so, and also, by the way, here we can see that delta, indeed, yeah, delta is equal to 0, so because we're going to snap it. And as you can say, if there is a delta, so then he's walking, okay? So we can say that this, my user, animation equals walking. Otherwise, so if delta is equal to 0, maybe this is better, the animation should be idle. But otherwise, he's walking, okay? So let's check if this works. If I click here, he's walking, and when he reaches, he stops. He's walking, and when he reaches the place, he stops. Cool. But he's not facing the right direction. So I'm going to say now that if he's walking, if delta is bigger than 0, he's walking to the right, then this my user facing is equal facing right. Otherwise, else is going to be facing left. Let's check now. I click, he goes facing there, stops, facing there. Cool. So we have something that's starting to look interesting. I can keep going for hours making this more beautiful, but for now it's important that you understand what I'm doing all the time and the main concepts here, okay? I'm trying to control the data based on the information I have, and that way it's way easier to instead of having, when I click the mouse, change all the state, the animations and everything. No. It's the state is going to be computed based on what's going on the other data. So at least I only modify the target, and that's enough to modify the rest of the values. Okay, cool. I think it's quite simple. Problem still is that I can get out of the room. Obviously, maybe I can have a function that says that the target cannot never be outside of some sizes. Like for instance, I can say that room has a size, like this size goes from minus 100 to 100, for instance. I don't know. So when I click and I specify where I want it to be, maybe I can control first, like I get the room. The room is easy because I have it here on my user. My user room. And I can say if my user target 0. I don't know why I put two vectors, vector 2, because it's just one number. Is smaller to room size 0. Okay, remember the size is left and right. It's not height and width. In this case, it's let's call it range maybe, because otherwise it looks strange to call it size and has two numbers. Let's call it range. Okay, so if it's smaller than range, I want it to be range. And if it's bigger than range, I want to range. That's the classical clamp function. If you ever have seen it, this function is very useful. I always have it in all my codes, which is clamp. You specify one value and a min value and a max value. And then if you return, if this value is smaller than min, you return the min value. Otherwise, if this value is bigger than max, you return the max value, and otherwise you return the same value. Okay, so this is the clamp function that is very common in many engines. I don't know why JavaScript doesn't come with this function. So remember that this is the ternary operator. If you don't know what it is, check on the ternary operator, because it's very useful when you work you are programming in any language. Okay, so now I'm going to say what when you in any moment I'm always trying to check that the target is always clamped. Okay, this value I want to clamp it between room range 0 and room range 1. Okay, so now at least I'm sure that if you in any moment by any reason you have clicked it and you have moved the range outside, it's not good. So if I click here, you can see works, but if I click here, I can't. Okay, it's not allowing me to modify it beyond some point. So now I have assigned some range. Because we have still 5 minutes more, I wanted to add another tiny feature that I think is interesting that you may want to use. And the feature is the next one. Now we have the camera fixed always in the center, and that makes sense because this room is small. But if we had a very big room that is full of, I don't know, longer than my screen, it would be very annoying to work that way. Okay, so it's always nice to have a way to control the position of the camera. I didn't put it here, but let's do it very easily. Let's call it offset of the camera. Cam offset, okay? Offset. So by default, the cam offset is going to be 0, okay? So that means that I want that if the cam offset is 0, it's going to be in the center of the screen, but if I move this cam offset, it's going to move like the camera is panning left or right. How can I do that? Well, it's quite easy. When I translate everything, it doesn't take much to say, hey, you can also use add the cam offset. So if I modify this cam offset, it's going to translate everything in the direction. Let's try now. If I go here, I have my code, and I go here and I say my app cam offset is equal to 10, it's going to move 10 pixels everything to the right. Okay, if I say 20, it's going to move another 10 pixels. By 0, it's going. So now I have a way to control the panning. The problem I have here is that this value, by the way, there's an error here because it's not taking into account the scaling. The scale is 4, by the way, which, by the way, I should have put the scaling outside. So maybe I'm going to say here, scale is 4, and I'm going to use the scale directly from here instead of hard coding it. Never hard code values if you can. Okay, and also here I was using this scaling and this scaling. Okay, so the thing I said is that I want to be able to control the camera because I don't have too much time now. I'm going to use the cursors to move the camera. That could be useful. If I want to know if when I press the mouse, the cursors to see what's the key, I'm going to go here and it's going to type, I'm going to press the cursor like left, right, for instance. And if I go here to keys, I can see here that there is the arrow left and arrow right is false because I clicked them. They store it on this container called keys that we set up before. So that means I know that I can control in any moment if that one key is pressed or not. So I'm going to go here to the update function and I'm going to see that if on the keys I have the arrow left, click it. I'm going to say that this cam offset delta multiplied by 10 maybe. And if I have pressed the right key, I'm going to do the opposite. Okay, so now if I press them, the keys is going to move, but it's very slow, so I'm going to multiply by 10. So you can see that I can control the camera a little bit, okay? There's a problem now. If I click now, you can see that the click doesn't, it's not in the right place, obviously, because in this function I created before to convert from world, I'm not taking into account the mouse, no? So I'm going to put also the translation, this cam offset on the X. So I'm going to put it, for instance, here, minus cam offset. Let's see if it works. So I click here, it works, but if I move the camera, I click again, it works, okay? Always, if you translate all your coordinate system, be sure that you take into account all the conversions, okay? Otherwise you will see strange things. But one of the things I don't like now is that the cam offset I'm using now, it's on pixels of the screen, okay? You can see it quite easily that I'm applying the offset, but then I'm scaling everything. So the offset is not taking into account the scale. It would be better if this offset was applied after I applied the scale. I can do that if I wanted to. I'm going to add another translation with only the offset, and I'm going to remove it from here. So the nice thing now is that this offset is in wall coordinates. Before it was in pixel coordinates of the canvas, now it's in wall coordinates of the game, okay? And because I have done that, this is going to, I have to move this outside of this operation here, okay? I think that's it. Let's check if it works now. And I crashed something. No, something wrong is going on. 1 second. So, sorry, yes, I translated 2 times. No, the height doesn't have to be translated, only the X. Okay, so it works. I can move the camera now, and it still works. Nice. You can see this moves much faster because now I'm moving 100 units of the wall, and the wall is way smaller. So I'm going to reduce a little bit the speed. And the reason why I wanted to have the movement of the camera using wall coordinates and not canvas coordinates is because now I can do this. I can say, as an example, okay? The offset of the camera is the position of my character. Let's see what happens if I do this. If I move to the right, oh, sorry, the opposite is negative. When I walk to the right, the camera is always following my character, okay? I don't know if this makes sense. It depends on what you want to do. So what I'm doing now is moving the camera as much as my character moves. So if the character moves to the right, I'm moving my camera to the right also, okay? So I gave this strange sensation that the camera is following him. Okay, and it doesn't mind how big the map is, it's always going to work. But it's very important, and I'm saying this is important about the coordinate system is because previous years, people do a lot of mess with the coordinate systems, and they usually end up with strange code that doesn't make any sense because they never make a function to convert between both systems, and they never tested the way that they converted in many places on their code. So always, this not only applies to 2D, it applies also to 3D when we do the third assignment. Always, when you construct any space, have functions to control the conversion of coordinate system from screen to world, from world to local to screen, whatever is the coordinate system that you're thinking. Here we have only two systems, which is the world one and the canvas one. We may have more. We can have also the person space, that like 0, 0 is always going to be in the center of the character. I don't know, depends on what you want to do. Okay. And that's mostly it. 1 second. Also, maybe if you wanted the camera not to follow so hard the character, there are tricks. So you can see that this value tends to the position, but it never reaches very fast. So when you start walking, it's going to slowly move in that position. So that would be something like this. Imagine that I have a linear interpolation function, the second function that you always need to have. So if you have two values and you want a factor to interpolate between them, you return the first value, multiply it by 1 minus f plus the second value multiplied by f. Okay, this function is also super useful when you have two values and you want to interpolate between them, both of them using a factor from 0 to 1. If this factor is 0, it's going to return a. If this factor is 1, it's going to return b. And if it's any value in the middle, it's going to return the values in the middle. Okay, this in programming is called lerping. So I'm going to say that this value is, instead of doing this, I'm going to comment this and say that the cam offset is going to be a linear interpolation between where is the camera offset now, where the camera I want it to be, which is here, but I want to have a factor that is always going to modify very slow. So what I'm doing now, for those of you who don't understand what I did now, this is something we do on games usually, is the camera is here, I want the camera to be here, so instead of assigning this value, I'm moving the camera straight here, I'm going to do between these 2 points, I'm going to interpolate like a little bit, so it's going to be like 0.01, so it's going to be just here, so I'm going to put the camera here. But because I'm going to do this every frame, the next frame is going to interpolate between this and this, so it's going to put the camera here. And the next frame is going to interpolate between this and this, and it's going to put it here. So at the end, what you get is this nice smooth, that when you move the character, sorry, the camera is following the character, but it takes some time to reach it. Okay. I don't know, it's not working very well. There's something when he reaches the place. Sorry, I put it inside this. I shouldn't be here, it should be here. I put inside this if, it doesn't make any sense. So now, yeah, if I click, he goes to this place and the camera tries to follow him and slowly stops. Goes to this place and the camera tries to follow him and he stops. And if we interpolate faster, instead of 0.01, we interpolate faster, it's going to be a little bit less, just too fast maybe. I'm going to go with 0.2 maybe, it's better. Okay, so we have control over the camera. It's always nice to have control over the camera when you make any application. So now we can do more interesting things. Okay, that's all. I know that I explained a lot of things. Most of the code is in, sorry, questions, can you upload this quick start you download during the lecture to the Discord server GitHub? No, I can't. And this is a very important thing. I know that for you, it would be super nice to take my code, copy it, put it in your code, and you have it. But I want you to code things from scratch. I want you to get your hands dirty, okay? All the examples I have used, they're mostly here on the slides, so it shouldn't take so much time for you to copy paste. But I want you to get used to code a little bit by yourself. If I gave you the code, I know what you will do. You will take the code, put it in your project, and start developing on top of it. You shouldn't do that ever. You don't take somebody else's code and start from there. What you do is you have the code in some slides, you check it, and then you think, oh, okay, I like what Javi did here, but maybe I'm going to need something else. Remember that we're going to need much more things on this application. I did it the fastest way in 1 hour and a half, but you should be able to do much more on this. And if I give you the code, you won't think what you're doing. If I force you to use it, yes, you're going to stop the videos and try to copy the videos. I know that's quite common on the students, but at least try to do it first, thinking about what you're doing it. The act of typing the code at least help you to understand what's going on. And if by any reason you mistake one character and do it wrong, at least you will have to go back to the code and understand it, okay? So that's why I don't like to give code. I like to code in front of you, so at least you see the code, you see my mind process when I work, but it's good that you get used to coding, okay? Very important. So for next week, what I expect is that you have the chat already working, and you have something that looks like this, similar. you don't have to follow exactly all the things I did here. You may want to modify something and do a different approach. Maybe you don't want to store the position that way. I don't know. Whatever you think it makes sense, you can do it. It's freedom. And this course is about how much freedom do you want to apply to your application. Also, if you gave me the assignment and all the code I see is my code, I can check every single line and it's exactly point by point my code. I know that you don't apply too much effort on the class. So please, please, please make an effort to code things in the way that you understand and not the way I do it. Okay? Cool. Next thing, what will happen if you introduce rotation to your coordinate system? How would you rotate the click mouse and map it? It's annoying. You have to use trigonometry. You can use matrices, but then you have to import functions for operating with matrices. And I have done that in the past. I don't recommend it. So in this case, I don't add rotation. Doesn't make any sense to use rotations. But yes, you will have to have a way to convert using a matrix. The problem with the current approach of transformations on the canvas is that it doesn't use a 4x4 matrix. It uses a 3x3, and it's very limited to the things you can do. But still, yes, it's possible to do rotations, and then you have to undo the rotations. Okay, cool. I don't understand the difference of applying the offset alone and applying the offset together with interleaved translation. There's no difference. It's just I wanted the translation to don't have into account the scale. It's not the same to translate scale, so translate and scale, than to translate the scale and translate. If you translate the scale and translate, the second translation will have the scale applied. And I didn't want to have it. So one trick I could have done is I played the translation of the half of the screen and the other one multiplied by the scale. I could have done that, but I just decided to put it below because it makes more sense. Okay, what will be the next deadline? Okay, deadline next week. We have the visual thing I did today working with more than one character. By the way, you to be able to have more than one character, and I expect that you start working on synchronizing users. That means that every user should be able to see other people on the same room. Okay, so that implies that you will have to start working on the backend and the state and all the things I have explained. Next week I will talk about synchronization, but at least you have something that you can have several characters on the same time on the screen. And the deadline is going to be in 2 weeks. So this week you are going to apply the characters moving on the screen, and the next week you're going to make the chat with the characters and people can move around. Okay, so 2 weeks, less than 2 weeks, 10 days from now. So well, go ahead, don't get sleep on that. And that's it. If anything else, I record everything. Today OBS didn't crash, so that means I can upload it in a half an hour to YouTube, so you can check it. And please don't copy the code all the time. Try to think by yourselves. Nothing I did here is so advanced that an engineer cannot use it. I mean, I use basic maths, I use basic operations, and I use functions that are kind of simple to understand, so it should be easier for you to apply everything. Okay, cool. If nothing else, see you on Monday where you have to show me all this. Bye.